Hello everyone. Now I'm going to talk about problem 9 for homework 8. The problem is show that for this Markov, if it is a Markov chain, then it is statistically determined by its second order probability masses, like this expression. We know that a process, for example xt, is a Markov process if the past has no influence on the statistics of the future under the condition that the present is known. This may be thought of as what happens next depends only on the state of affairs now. In other words, for this problem, it means that knowing the joint probabilities of any two states in the chain is enough to determine the entire chain. So we can know that it is exactly the probability of xn under the condition of the situations from n-1 to 1 times the probability of this situation happens. So I just copy and paste it here. We can use the chain rule to deal with the joint probability from n to n and n-1 and n-2 and so on until 1. So finally we can get xn under the condition of n-1 times n-1 under the condition of n-2 and so on until x2 under the condition of x1 times the probability of x1. So consider the marginal probability of a single state. It is the sum of the joint probabilities over all possible values of k. That is, when we consider the one situation of xi, it is the sum of this and so now we consider the conditional probability of the state I. Now we use this format. It should be something like this. And it is equal to a ratio of the joint probability of this and this. And the marginal probability I minus 1. This happens because we can use such a function and this and such function to divide them one by one, and we can just get to know this conclusion. So this is just the format to confirm that it is statistically determined by its second-order probability methods. That's all. Thank you for your listening.